Viewers, welcome back to the channel Maths with Berlin. So today we have another JEE Advanced relevant question, and this is specifically for 2005, right? You may change the value of the 2005 if you are an aspirant from 2006 or 2007. You may change the value of 2005 and try the problem. So those who want to give this problem a try, they may pause the video right here and give it a try. For the others, I will be just giving a formal reading to the question. So it is given that the equation r squared divided by x minus r from summation r equal to 1 to 2005, right? That is given to be equal to 2005 squared. Now we have been asked about how many real values or how many real roots are there for this equation, right? See, the answer, if you would like some options for this one, I would be very much obliged to give you the options that were there. The first option is infinity, right? That was the first option that was there. Option B that was there, that is 100 and 1012 roots, real roots. And the third option, that is option C that was there, that is 1013 roots, real roots. And option D that was given was 2025 real roots, right? Now if you feel that it is an identity, you might be correct. If you feel if it is option B, you're definitely wrong, right? See, you need to understand what is option is. Basically this is 1013 real roots, imaginary roots, right? If 1012 real roots are there, therefore all the others are imaginary. But basically if you see, if there are 1013 imaginary roots, that is not possible because imaginary roots always exist in pairs, right? Pairs rule is not being followed, right? So that can never be an answer, right? So our main target is basically this is option B is cancelled out, right, from the picture. Now our main targets are these three options, that is option A, C and D, right? So let's just move on to the solution part of the video. So for solution, what I have assumed is, I assume that the equation has a root z, that is a plus iota b. So if you remember one thing, that is you must remember this circles, right? That is complex numbers. Inside it there is a part that is of real numbers, and inside it there is another part that is of whole numbers, and inside it there is another part that is of positive integer, not whole numbers, whole numbers. After that there are natural numbers and all sorts of that, right? You must remember this part, that circles, right? So what I assumed is, I assumed a bigger one, that is complex number. So if b is equal to 0, it will be a real solution, right? If b is equal to 0, if let us add a if here, if b is equal to 0, this will be a real solution. So rubbing this part a bit so that we can get the space for the rough work. So we have taken that the root of the equation as z, that is equal to a plus iota b. Then what we can say that the complex root of the following will also exist, right? Because complex roots always exist in pairs, right? Complex roots always exist in pairs. So therefore this is also a solution to the equation. Now put these values into the given problem, right? What you get is that the first equation that you get, the first equation one, and there is another second equation that you get, right? When you put these values here. After that, what we do is we just subtract the equation 2 from equation 1, equation 1 from equation 2. We subtract equation 1 from equation 2. And that results us into the following simplification, that is r square into 2 iota b divided by a minus r whole squared plus b squared is equal to 0, right? That is equal to 0. And you know the limits that are ranging from r equal to 1 to 2025. Now, therefore, what you can say from here is that b is equal to 0. Can you say that? Because this is a positive number, right, and it is not equal to 0. This is also a positive number not equal to 0. This is also a positive number not equal to 0. No, wait a minute. This is the denominator is being a total is a positive number, right? The denominator, this total is a positive number. You cannot say about the individual elements, right? You cannot say about individual elements of the denominator, but the denominator as a total is a positive number. So the only number that is remaining, the variable that is remaining, that is b. That can be equal to 0, right? And that must be equal to 0 for the following to hold true. So therefore b must be equal to 0, and therefore all the roots are real, right? And therefore the answer is that 2025 real roots are there for the equation. So that's it for today. Thank you everyone.